All right. So Monday, a couple days ago, in the first video, first call, we talked about knowing how to compare functions. We talked about comparing linear, quadratic, and exponential functions, and doing so by taking the first and second differences of the y values. That's a lot of math words, but if you think back to the t-charts that we were using, the tables we were using, and the numbers we were actually working with, we were working with the y values, okay? Our x values were increasingly constant. They were going up by 1 each time, and so we were looking at the differences in the change in the y. That's just kind of like a recap of what we were doing. And what we're doing today is going to directly build on it in a little different light, okay? So I wanted to kind of use the vocabulary again, first and second difference, and we talked about that with linear equations, and we talked about that with quadratic equations. So one more time, with linear equations, there was a constant first difference, and with quadratics, there was a constant second difference. Okay. With linear, there was a constant first difference, and in quadratics, there was a constant second difference. Now, we knew we have three categories we're going to talk about. That third is obviously going to be exponential. That's what we learned about right before we got out. That test you just missed, right? Now, we kind of have to figure out what's going on there. So that's what we're going to pick up in the Cami document, and that's what we're going to pick up in the notes. And so go ahead and you can listen to me, or if you have pull up me on your phone while you take notes on your Chromebook, that'd be great. Or if you want to just kind of go back and forth, that's also good. So let me draw my table again. And let me have my x, and then my y equals 2 to the x. All right. And then it has first difference, second difference. Okay. Again, it's -3, -2, -1, 0, 1, 2, 3. Okay, just copying down the notes there. Not pulling anything out of thin air yet. Okay, so remember, this is our x values and this is our y values. To get the y values, you need to plug in x, where it goes, the numbers, the values for x. -3, -2, and so on. So I'm going to kind of write it out at first and then solve it and then go from there, okay? So to start, -3, what this would look like would say 2 to the -3. That's how I'm going to start my chart. I'm going to get a little equal sign. I'm just going to fill it in, plug it in, substitute it in, the value for x all the way down the line. 2 to the -1, 2 to the 0, 2 to the 1, 2 squared, 2 to the third, 2 cubed. Okay, now I have to actually do some math there because I can't calculate my differences yet, so I need to figure out what's going on there. So 2 to the -3, this is when the Desmos calculator is handy. Again, this is going to be all online. I'm glad we worked with that tool beforehand. But also, what would be nice at this point, if you just kind of know some of them, it's also good. You can kind of fill in the table as you go. But for sake of time, 2 to the -3 is going to be 1/8. 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 raised to the second power is 4, 2 squared. And then 2 raised to the third power is 8. Okay. So before you go copying down notes in the Cami document, get to here. In this next step, I want you to just pause on the notes and actually just watch me for a second. So I'm going to do some talking and kind of explain some stuff, and then we're going to get into what I actually want you to write down in the notes to make a difference, okay? To kind of show you the meat of what I want you to get to, okay? So let's follow the same process as before and look at the first and second differences, figure out if it's linear, if it's quadratic, or maybe if it's exponential, what does that look like? All right, so let's start with the first difference, and let's start by subtracting the second from the first. I'm going to clarify some words here, some terms, because I kind of messed up on Monday. The process is actually concrete. What you need to do is subtract the second from the first. So subtract the second one from the first one, the second one from the first one, okay? In that case, it's going to be 1/4. And then we subtract 1/2 from 1/4. Oh, got that wrong. It's 1/8. 1/8. Then we subtract 1/2 from 1/4. Hold on. 1/8 minus 1/4 is going to be 1/8. Yeah, I had that right. Minus 2/8. Okay, which is negative 1/8. Too early in the morning for me, huh? Spring break got to me. Negative 1/8 there. All right, let's keep on moving. And then from 1/4 minus 1/2 is 1/4 minus 2/4, which is negative 1/4. Okay, so negative 1/8, negative 1/4. Subtracting, keeping going there. Negative 1/2, negative 1, negative 2, negative 4. Okay, that's a problem because that's not a constant, right? That's not the same number every time. It's not ones, it's not threes, it's not something consistent. So it's not linear. That tells us it's not linear. So we got to move on to the second difference. Let's check that real quick. Again, pause on the notes and just let me talk for a second. Now we look at the difference here. Okay. But look at those differences there, and we follow the same pattern. If you notice, let's just start here because these numbers are a little bit easier to see. 1/2 to negative 1/2 to negative 1 is not the same as negative 1 to negative 2, or negative 2 to negative 4. So that's not consistent either. The second difference is not constant either. We don't have a constant difference first or second. It's not linear or quadratic. If it was consistent here, it'd be quadratic, but it's not. So we got to move on to the next thing. This is why I said pause in the notes. Is because when we're dealing with exponential graphs, what we're actually looking for isn't addition or subtraction in our differences, but multiplication. Okay, bear with me. All right. So what we need to look for is a multiplier or a multiple or a factor, a number that you're going to multiply the first number to get the second number. First, second number to get the third, third to get the fourth, and so on. Let's start with the first two. Okay, and to find that, you're looking for a ratio here. And to find that, you take the second number and then you divide it by the first number. And that should give you 2. Calculator helps there, and so on and so forth. So you take the second number, let's check and make sure that ratio is correct. It also gives me 2. Okay, and so 1/2 divided by 1. Or I'm sorry, 1 divided by 1/2. Switch them, right? So again, another brain fart there. And then 1 divided by 1/2. And then 2 divided by 1. 4 divided by 2. 8 divided by 4. So you take the second number and divide it by the first number. That's how we do ratios anyways. The Zoom calls got me messed up. Okay, so what I'm doing here, clean up that mess, is I'm taking the second number, 1/4 or 1/2, and dividing it by the first number in the little pair that I'm drawing the arrows between, or that little caret, little symbol we did yesterday as well. Works fine. Fractions are scary, I get that, but don't be too worried. You can put that in the calculator. So what we found here was actually a ratio that allows us to not add or subtract to get the common difference, but actually multiply or divide to get the common difference. It's going to be multiply because what I want to check here is, let's look at these numbers one more time. Let's see if that 2 number actually holds and is important here. So I'm going to draw in blue, kind of my rethinking of everything. Let's look at 1/8 to 1/4. To go from 1/8 to get to 1/4, I have to multiply it by 2. To get to 1/4 to 1/2, I'm going to multiply it by 2. To go from 1/2 to 1, I'm going to multiply it by 2. I'm not going to add or subtract. Instead, I'm going to multiply by 2, and that actually holds for all of them. Okay, so that's the third option for exponential, what we're going to add today. Is a constant ratio or multiple. We knew that though. It's the first time we're looking at it in this light, but that's not brand new. Okay, the idea, I guess, isn't brand new. Because with exponentials, you know, if you have 2 to the third, it's like multiplying 2 times 2 times 2. Or if we start here, 2 times 2 times 2. Okay, so the principle is still the same. We're just looking at it a little differently. So when you're dealing with exponentials and you have to do this first and second difference, know that you're not having to add or subtract. Don't look for a constant difference with add or subtraction, or addition or subtraction, but you need to look for a constant difference with multiplication. And that multiple might be a fraction, so multiplication or division. Okay, here it was multiplication, multiply by 2. All right, remember to open the chat box if you have any questions. I know I just kind of fumbled around the first start of that, had to collect my thoughts, but I need to make some room. So the beauty of the YouTube video is pause it if you need to finish copying down, but I'm going to keep going. And this will be posted. Had some issues yesterday making the channel, but today it won't be too bad. Post it as soon as I possibly can. Okay, so there's a couple questions here. And it says, what do you notice about the differences in this function? Okay, so this function, the difference we just talked about, it's actually multiplied. So what you know, instead of added or subtracted, something you could write there was it's actually multiplied to get the next number and the next number. And it says, by what number is the first difference values multiplied to get the next. We talked about that a few seconds ago. That's going to be 2. That's the number we're multiplying to get the next, and the next. Let me rewrite that equation one more time because I want to talk about some stuff here. This next question is actually really interesting. That's the equation that's in the table. That's the one we're dealing with. But that common ratio, that common, the difference that we're multiplying, is multiple of 2. They're both 2. Weird. Okay, so we have a name for this 2, though. That 2 is in a very specific spot that helps us kind of navigate around it. That 2 is the base. That's the base. Remember that? The base of the equation, the quadratic equation, or the exponential equation. It's the base. So what is the value connected to? It's the base. So in the future, that's something you can kind of immediately go to if you're dealing with an exponential and you need to know the common difference, or you know the first difference or the second difference. Look at the base and see if it's exponential. Look at the base and check and make sure those are whole. But that's kind of your hint, okay? Your little cheat sheet there. And then again, this is going to be exponential. And then what methods could you use to verify this type of function selected? It's going to be, you can graph it. That's one of the other methods you could do. Use the first and second difference, that kind of idea. Okay, so this today might run a little bit long because I fumbled over myself a little bit there, but bear with me. Again, you can dip out if you need to. So I'm actually going to work through, if you look at number 2 on your notes, it says use differences to identify the type of function. So first and second differences to figure it out. Okay, and it gives us 4 options. All right, so I'm actually going to do the first, the second, and the fourth because that gives us easy to understand use of each one. Okay, so if we start with the first one, our x, y table, notice it doesn't give us the x values and the equation this time. It just gives us the table, which is fine. Don't panic. I don't know if you can hear my cat meowing. Wants to get in. 5, 8, 13, 20, 29, 13, 20, 29, 40. 5, 8, 13. Okay, so what you would do is the same process as if we had the actual equation. What you're going to do this time is you're going to, instead of that middle step of solving for the y values, they're given. So we can start with the y values here and figure out the first and second differences. So we'll make this one the first difference. So I can draw these little things if you prefer those. So we're going to just remember, reduce for every single one, every single pair. From 5 to 8 minus 5, or I'll write it out, 8 minus 5 is 3. That's my first difference. 13 minus 8 is my second difference. Or sorry, for the second pair, my first difference for the second pair. 20 minus 13, 7. 29 minus 20, 40 minus 29. Okay, you have to subtract the second from the first from the second, and then that'll give you your first difference. Now let's move on to the second difference. And the process is still the same. The pairs are just going to be new. Okay, so let's look at those two. 5 minus 3 is, so I'll write it out. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. Okay, so that's not constant, so we had to move on to the second difference. But the second difference was constant. That's awesome. Second difference being constant, so this is actually quadratic. Take a second, think about that. I'm gonna visitor. This is our math partner today. Okay, so I think he agrees. He doesn't want to be a camera shy. The first difference was not constant, so we had to move on to the second difference. Because the second difference was constant, tells us it's a quadratic. Okay, now the thought process we had to have here. So let's take this. Again, you can pause it. And if you have questions, what's super cool about the YouTube video is you can send me a timestamp. You can say, hey, 5 minutes and 25 seconds. What in the world were you talking about? That way I can know kind of what you need to know, the exact moment where you had a question. So let's look at the second one here, -5, -4, -3, -2, -1, 0. 36, or sorry, 32, 16, 8, 4, 2, 1. All right, so first things first, let's check that first difference and then the second difference with addition and subtraction. And then let's see if either of those work, and if that doesn't work, let's move on to exponential, the multiplication. All right, so let's check the first difference here. What we do is we take the second one, so 16 minus 32 is -16. Take the second minus the first, and again here we'll take the third minus the second, so 8 minus 16 is -8. Process is still the same. So where I'm drawing my arrow to, you take that number and subtract it from the previous number. And that process is all going to be the same process. No questions yet. All right. So we got -16, -8, -4, -2, -1. Definitely not constant. That's okay, right? Because now we're going to move on to the second difference to see if it's quadratic. So what you're all still going to do is take this. If you notice, this kind of takes a lot of room. There's not a ton of room on the paper. So having your own paper off the side might be beneficial. Scrap paper, right? Scratch paper. So what you would do here is take -8 minus -16. We know that turns to a positive. That gives us 8. Change in 8. Now we have -4 minus -8. Those negatives become positive. That gives me 4. Uh-oh. We have -2 minus -4. Those two become positive. That gives me 2. We have -1 minus -2. Those become positive. That gives me 1. But here we are with a second difference that's not constant. Don't panic, because we actually learned about what to do here. If we know that it's not a constant first difference, it's not linear. If it's not a constant second difference, it's not quadratic. We got one more option left. Cat's walking all over the table. We got one option left, and that's exponential. We have to check that and make sure to do that. If you're still copying the second difference, I'll actually do this below. How about that? I'll do this underneath. So let's try again with the values here. Let's try with x, y, -5, -4, -3, -2, -1, 0, 32, 16. Can you see that? It's right in the glare, isn't it? I'll go up a little bit here. Okay. So x, y, -5, -4, -3, -2, -1, 0. 32, 16, 8, 4, 2, 1. All right, this is gonna be our third option. That was our first chance, didn't work. Second chance, didn't work. Holding for that third option. What we need to do is see if there's some number, some ratio we can multiply the first number by to get the second number. And to find that ratio, take the second divided by the first. That should give us the ratio. So I'm going to draw my arrows again. I need some more colors. Draw my arrows again. Now I'll take 16 divided by 32. That should give me 1/2. And that process needs to stay. That needs to be the pattern and the process that we take to solve this. Sorry it took me so long to, I guess, find the right words. I wrote it out, but it didn't come out right. 2 divided by 4, 1/2. 1 divided by 2, that gives me 1/2. Okay, so we have a ratio now, or a multiple that will give us, it's constant, right? That's good. That means when we're going to from 32 to 16, we're multiplying by 1/2. We're going from 16 to 8, we're multiplying by 1/2. That's what we just found. That's what all this mess is. Our constant difference is actually a multiple or a ratio this time, which is good. That tells us it's our third category of options, which is exponential. Okay, so that means this one is exponential. The first one was quadratic. This one is exponential. Okay, again, good thing it's a YouTube video. You can pause and come back to it, but I'm going to keep moving. Well, I'll leave that while I write these numbers. If you have any questions, please do put them up there. Yeah, I know there's only a couple of you, but I can't know what you don't know unless you tell me. So I'm going to move on again to the last one, the fourth one, to 0.5, I think, 0.75, 1. Okay, that gives me 0.9, 1.1, 1.3, 1.5, 1.7, 1.9. All right, so here's my hope. My hope is that it'll be a first difference because that makes life easy. And if it's not a big deal. So let's check it here. I'll do it in blue. What you want to do is you want to take the second number, 1.1, divided by, or not divided, subtracted 0.9, and then you will get 0.2. The second minus the first, that gives me 0.2. The second minus the first, process stays the same, 1.7 minus 1.5, and 1.9 minus 1.7. Okay, cool. So we have a constant first difference this time. Again, this is all the first difference, and that tells us it's linear. So we don't have to keep continuing because it is constant. Again, we're fishing for that constant difference, whether it's a first and it's addition or subtraction, whether it's a second with addition or subtraction, or it's a first with a ratio. Our three categories. We got three options, and we got three categories of equations that we talked about. Okay, if it's none of those things, like if none of them fit, nah, right, NA. We don't have a description or a descriptive for it yet, okay? So those are our three options and kind of an example for all three. This next bit of questions is kind of the same as the practice problems, similar to the practice problems that will actually be kind of like the assignment at the end. Okay, so when you submit this on Friday, this is going to be all your notes. I'm going to look at all the notes, make sure you took them, and you're actively trying with those, and then got some practice problems at the end that I want you to answer. Okay, and there's 6 of those, and they kind of follow similar to 1 through 6 here, this next little bit, where it says identify the following equations as linear, quadratic, or exponential. Okay, so we know a couple things. Let me get rid of all this and then kind of talk about what we know and how we can, a couple ways we can go about this. All right. So what it wants us to do, identify them as linear, quadratic, or exponential. All right, so linear, probably going to follow mx plus b. Quadratic is definitely going to follow y. Well, not definitely. Most likely going to follow standard form. Or we also know it's in, you know, and then this one. Okay. We have two forms for quadratics. I think they're all going to follow this form, some variation of this form for linear, and then exponential as well. So I want to talk about some key differences that you can kind of just look at in the function and see, like which one it might fall into. So if you look at number 1 and number 2, so number 1 is 10 to the 1/3 to the x, and number 2 is 5 plus 7 times x. Okay. The key difference here, what I see, and it kind of helps me compare two of them, right? Well, the exponent, the variable, the x, is in the exponent. Red flag. That tells us it's exponential. Kind of straightforward. What's good about this unit we're in now, and the stuff we're talking about now, is once you start gaining traction and you understand what linear functions are, exponential functions, and quadratic functions, it's going to keep repeating, and a lot of these same ideas are going to keep coming up. So we see that this, to me, looks most similar to this because the x, the variable, is in the exponent. It's up in the air. Compare that to this one where it's on the ground, but also there's no exponent on it, right? There's no square. If there's no square, it's probably linear, right? Because that's the difference here. The x is squared, but down here it's not. So it's got to be linear. Kind of just comparing and contrasting and using what you know about all this to do so. All right. So again, I want you to check one of those boxes. However, another way you could do this, which is kind of what I would want you to do on the last couple, is try it a little bit with the with actually doing the table and stuff. So what we'll do, you can just do like 4 values, that's fine. 4 or 5 values here, so we have x. Let's do -2, -1, 0, 1, 2. Calculators are your friend here. And then you would kind of follow through here. So 10 to the 1/3. -2. 10 to the 1/3, -1. 10 to the 1/3, 0. 10 to the 1/3, or 10 times 1/3 to 1. 10 times 1/3 squared. Okay, hopefully, yeah, it's not too low. So again, your calculator is going to be handy here, but I think that gives you 90, 30, 10, 10 over 3, and 10 over 9. So then you can kind of go from here and look at 30 divided by 90, 1/3, 10 divided by 30, 1/3. Your calculator will help you here. You can do that fraction and repeat that same process down the line, and you're going to find that the constant first difference is going to be 1/3. Again, multiplying by 1/3. That's kind of what you want to do for those. So Number one, there's not a lot of room, I get that, but a couple different ways we could do it. Graph it, work through it first and second difference table, or just comparing and contrasting the makeup and the build of the equation. Okay, but there's a pretty key important part of the notes there right after this. So let's look at it together. I want you to try 3 through 6, okay? And give me some questions. If you need some help, let me know. But I want you to try 3 through 6 because that's important. Check one of the boxes with the equations that it kind of aligns with for those. All right. So right here, this is big. This is kind of the key, the biggest point of all this that I want you to get out of this first and second difference stuff. It says all blank functions have blank. That's the first one. Then it says all blank functions have a blank. And then it says all blank functions must have a blank in the blank. Okay. So we have 3 different kinds of functions. The stuff that's going to go in the first blanks. We talked about comparing linear, quadratic, exponential. That's going to help us figure out what's going in the rest of the blanks. Okay. So all linear functions have blank. Constant. I don't know why there's not an A there. Grammar, right? Constant first difference. All quadratics follow the same pattern. Functions have a constant second difference. And then all exponential functions must have a blank in the blank. Yes, did you have a question? I can. I'm not going to because it's recorded. So just type any questions you have. If we need to have a chat later, we can. So all blank exponential functions must have a blank. So I have here in my notes a multiple slash ratio in the, I put in the first difference because that's kind of what we've been talking about. All right. Try your best to type it out. If you can, type out a question. So all exponential functions must have a blank multiple or ratio in the first difference. All right. That's kind of the meat there. So what's funny is, I looked at this and I kind of made it the first time. It was good. I hadn't solved it all yet. And then I got to the graph and I realized that it's terrible. It's the axes are all kind of off. The numbers are in the middle of the lines, and it's like in the middle between the 2 lines, and it's bad. It's real bad. So skip that. Okay, if you've gotten to this point of the video and you're not trying to do it all on your own, here's a hint. Skip that part where it says graph the functions and talk and write a little bit about them. We don't need that right now. I'll come back and reteach that later. Skip that. I know our videos run a little long today, but thank you for bearing with me. Skip that part. And this is the 3 lines of notes that'll be super important from all this. All right, and I want to show you one of these problems, 1 through 6, that are your own on the end there, and that's kind of what I want you to do. But I'm actually going to look at number 5. I think it should be y equals. So what you'll do in all these blanks is draw your xy chart. Okay. We have negative, and you can just do -2, -1, 0, 1, 2. And what I would do actually is kind of follow the slow process by going 3 times -2 plus 3, right? Writing all that out and then solving it just makes things a little cleaner. Okay, so now I have all that written out. We can look at it as 3 times -2 plus 3. 3 times -2 plus 3. So 3 times -2 is -6, plus 3 is -3. 3 times -1 is -3, plus 3 is 0. 3 times 0 is 0, plus 3 is 3. 3 times 1 is 3, plus 3 is 6. 3 times 2 is 6, plus 3 is 9. Okay, so now that I have 0, or -3, 0, 3, 6, and 9, what I'll do is I'll take my first difference column, and I don't need any more if it works. So let's check it. So 0 minus -3 equals 3. 3 minus 0 is 3. 6 minus 3 is 3. 9 minus 6 is 3. We have a common first difference that tells us it's one of the 3. Well, they're all going to be one of the 3 options. Our common first difference tells us it's going to be linear. I know you could probably just compare the equations and look at them and say, hey, it's a standard form, so it's quadratic or whatever. But for the process of these 6, what I want you to do is go through this. Okay. Now, Ms. Tillman will be live tomorrow and help out if everything's still according to schedule. And if need be, I can come on Friday and go live on Friday and kind of work some out. However, I really want you to try this on your own. And if you're super stuck, you're already on YouTube. If you're watching this after the fact, go up to the search bar and just search first and second difference. Hit enter. There's a bunch of good videos. The Khan Academy one's really good. You can kind of piece together a lot of this stuff. Now, can't piece together all of it, right? And we know you better than YouTube knows you. So if you need help, please, please, please do let us know. Send us an email, a message, a remind, whatever it is. But from here on out, I'm about to take any questions. I'm going to stop recording, take all questions, and then I'm going to post it here in a second. So again, as we're filling out the notes, if you want to star and highlight next to those 3 lines of all blank functions, those 3 lines are the most important. Skip that graph part, and then for 1 through 6 in the back, do it looking like this. Okay, that's the plan. And this will be posted here in a second. So again, this is due Friday night at midnight, or 11:59. Okay, so you got a minute. Don't panic. And I will stop the recording now.